Hey everybody, this is Chris back with another Proto Tech Tip, and for this week I'm going to be discussing something that we haven't covered before in our Tech Tip series, and that's geometric dimensioning and tolerancing, which is thankfully commonly referred to by its acronym GD&T. This is going to be a brief introduction to GD&T, but we are going to dive deeper into the topic over the next few weeks and months. So with that being said, let's jump into it. At ProtoCase and Protospace MFG, we can custom manufacture your parts and enclosures in as fast as 2 to 3 days, which can help you cut out any latencies and accelerate your project velocity. Now, you know that manufactured pieces can differ in size and dimensions from an original CAD model due to the variations in the manufacturing processes. But to optimally control and communicate that allowable variation, engineers and manufacturers working under ASME standards, which is the American Society of Mechanical Engineers, uses a symbolic language called GD&T, the short for geometric dimensioning and tolerancing. On the other hand, ISO uses geometrical product specifications, GPS. GD&T and GPS are very similar in their symbols and principles, but they have some very important differences that we're going to cover in a future tech tip. So GD&T shifts the focus from perfect geometry to focusing on critical features for function while allowing for more flexibility for non-critical features. It precisely defines how parts should be measured and what references to use, ensuring that inspections are both repeatable and defensible. In GD&T, a standardized system is used to define and communicate engineering tolerances and part geometry. It uses a symbolic language to precisely describe size, form, and orientation and location of the features on a part. This allows engineers and machinists to inspect and understand how a component should be manufactured and how it's going to fit or function within an assembly. So let's start off by looking at this particular drawing. This is a fully defined drawing. There's nothing preventing us from manufacturing this part, but it may be missing some critical information that identifies the truly important features. There is no GD&T on the above drawing. Can the OD be out of round? Does it need to be concentric? How non-flat can the front face be? So let's look at the drawing now with some GD&T applied. You can now see that GD&T ensures that the functional requirements of the assembly are transferred down to the individual parts. Universal symbols such as flatness, perpendicularity, etc. are placed on the drawing to reduce the writing contained in the drawing itself. Now generally, when applied correctly, GD&T ensures that functional features not meant for printing are kept separate, maximizing productivity while also maintaining the intended form, fit, and function of the design. GD&T also helps create a more thorough design process. As a designer, you can define dimensions based on how mating parts relate to each other, which keeps the focus on the assembly's function and of course eliminates the guesswork on the shop floor. So a common misconception about GD&T is that it tightens tolerances and makes parts harder to manufacture. In reality though, it often provides more tolerance. In traditional coordinate dimensioning, a hole's location is usually defined by a square tolerance zone. However, a hole is round. If a hole falls slightly outside the square corner but is still functional, it would technically be rejected under traditional rules. GD&T uses diametric tolerance zones, which offer 57% more tolerance area than a square zone. Look at these two diagrams. The boxes surrounding a dimension represent basic dimensions. These dimensions are theoretically perfect and are driven by the tolerance within a feature control frame. Since the tolerance has a diameter symbol in front of it, this indicates that it's a diametric tolerance zone and not a coordinate tolerance zone. Please note though how these two tolerance zones differ from each other. Now let's look at the implementation of GD&T in your design, which involves applying specific symbols and rules to the features of a part. First, let's discuss datums. A datum is a theoretical reference point, line, or surface on a part that serves as the origin for measurement and manufacturing. It acts as a frame of reference against which other features are defined and inspected. ensuring consistency in how parts fit and function together. Datums are usually selected from important functional surfaces or features, such as a flat face, a hole, or an axis, and are going to be labeled with capital letters. Now let's talk about feature control frames, which is the heart of GD&T. It is the core communication tool used in GD&T to define the specific geometric requirements of a feature on a part. It provides a standardized symbolic way to describe how much variation in form, orientation, location, profile, or runout is acceptable. Now here's a chart that shows you the different symbols and what they describe. Please note that this is the 2009 standard. In the 2018 standard, concentricity and symmetry were removed, with position driving both of these symbols in the 2018 standard. However, since many designers still use these symbols, we're going to be displaying them in this video. And as you can see on the chart, there are different types of tolerances, namely form, profile, orientation, location, and runout. Form controls the shape of a feature, while profile controls the outline of a surface. Then there's orientation, which controls the feature's tilt, and location, which controls its position. Finally, runout controls how much a feature varies as the part is rotated. Now, I promise that we're going to go into more detail about this in a future tech tip. So to conclude, mastering GD&T helps you reduce confusion, lower costs, and ensure that your final product assembles exactly the way that you planned. Whether you're designing a simple bracket or a complex aerospace part, GD&T can help you turn your design into a functional part. Now, as I said earlier, this is the first of many Proto tech tips on GD&T, so please, you're going to want to subscribe to the channel to catch more GD&T content coming soon. Thanks for watching, and until next time, take care.